I can't believe we're on a spaceship! I know, it's awesome! What's that on the horizon? It's huge! It's a star!
Allie, the science guy.
Ali, the science guy.
Jess. Allie, the science guy.
Science rules!
Allie, the science guy.
Earthquakes are shaky!
Jess. Allie, the science guy. Jess. T minus 7 seconds. Jess. Allie, the science guy.
I can't believe we just saw a star! How did you guys know that was a star? Ah! How did you get here? I was here on the space station. We can tell from the characteristics. And go. Go. The color, temperature, size, composition, and brightness all told us that was a giant star. Much like us humans, stars have a life too. Really? First, a star is born. A star is born when contracting gas and dust becomes so hot that nuclear fusion starts. Nuclear fusion is the process when atoms of hydrogen combine and make helium. During this process, a lot of energy is produced. That makes sense. How long is a star's life? A star's lifespan depends on how much mass it has. Oh yeah, stars that have more mass than the sun have shorter lifetimes. You might think that stars with more mass will last longer than stars with less mass. Is that true? No, you can think of stars being cars. A small car has a small gas tank, but it also has a small engine that burns slowly. So a larger car, on the other hand, has a larger gas tank, but also has a larger engine that burns gas quickly. Do stars die? Yes, a star does die. When a star dies, it basically runs out of fuel. So like a car runs out of gas on the side of a road, that would be really bad. After its death, it turns into a white dwarf, a neutron star, or a black hole. Small and medium stars' lifetimes last 10 billion or more years. The outer part of a star gets bigger and they become red giants. Eventually, the outer layers get bigger and drift out into deep space. The core of the star is left behind and becomes a white dwarf. A white dwarf is about the size of the Earth. A dying giant or supergiant star will suddenly explode. A few hours later, the star is 1,000,000 times brighter. This is called a supernova. After this happens, material from the supernova may become part of a nebula. After the explosion from the nebula, it forms a neutron star. The most massive stars become black holes when they die. After the star becomes a supernova, the gravity of this mass is so strong that the gas is pulled inward, packing the gas into smaller and smaller space. Okay. When things get trapped in the black hole, they can't get out, even light. So, now let's do a lab. This is a small medium star, and it's just been born. So you can see it has all of this mass, and so a billion years later, it's used up a little bit of energy. Another billion years later, it's used up a little more. And by the way, this is just a volleyball with construction paper taped around it. So that's how you can do it at home. So another billion years later, it's used up a little bit more mass. A few billion years later, some more. Until it's been around 10 billion years, and it's used up all of its mass. And it's now become a white dwarf. So that's how a white dwarf forms. Whatever.
Now let's talk about the different types of stars. The first one is a white dwarf. Medium star. Large star. And a giant star. Okay, jobs, Allie and Jessa.
I hope you guys understand a little bit more about stars.
Now let's learn a little bit more about stars.
How bright do stars get?
Well, actually, 2 scientists around the world had the same question.
Oh yeah, wasn't it Ejnar Hertzsprung and Henry Norris Russell?
Oh yeah!
Yeah, they made a diagram called the Hertzsprung-Russell diagram. They wanted to find out the temperature and brightness of the stars, so they made a graph. So actually, if you look on page 132, you will find the diagram, and it looks like this. They wanted to find out the temperature and absolute brightness of the stars, and so they put the surface temperature of the stars on the x-axis and their absolute brightness on the y-axis. So basically, as you can see, these points formed a pattern. So astronomers today still use this pattern. And again, it's called the Hertzsprung-Russell diagram. Now let's talk about measuring the distance to stars.
So first up is a light year. Astronomers use a unit that is called the light year to measure distances between stars.
So how long is a light year?
A light year is the distance the light travels in 1 year, about 9.5 million kilometers.
Wow, that's pretty long.
How fast does it travel?
It travels at a speed of about 300,000 kilometers per second.
Holy cow! That's fast.
So another thing we can talk about is a parallax. So now let's talk about a parallax. What's a parallax? Let me tell you. A parallax is an obvious change in an object or like a person. So yeah, let's do a lab on parallaxes.
We're going to do a lab showing how a parallax works. So I'm going to read the instructions, and so Jessie, my lovely assistant here, is going to act it out as I explain. Okay, so this is the lab. How does your thumb move? Stand facing a wall at least an arm's length away, or a mirror, that works too. Stretch your arm out with your thumb up and your fingers curled. Close your right eye and look at your thumb with your left. Line up your thumb with something on the wall. Now close your left eye and open your right eye. How does the thumb appear to move along the wall? Bring your thumb closer to your eye, about half the distance as before.
That's so weird. I'm making like such a weird face.
No, you're not.
Okay. Bring your thumb closer to your eye, about half the distance as before. Repeat steps 2 and 3. And so you all better be doing this in class, otherwise
We're watching
yell at you.
We're watching you.
How does your thumb appear to move in step 4 compared to step 3? So step 4 was when step 4 was when your arm is about here, and then step 3 is out. 3 is here. What's the difference in change between the distances away from your body?
about how to classify a star. So basically, the characteristics of a star help classify a star, I guess. So let's talk about the classifying star. So how do you classify a star? I'm going to tell you. So a few ways to classify a star is by its color, temperature, size, and composition. So Jesse will be talking about composition, color, and temperature, and I will be talking about the size.
Okay, so first I'm going to talk about the color and the temperature, and how the temperature affects the color of the stars. So if you can think about, like, on Earth, there's this thing called a toaster.
I've heard of it.
And so if you look inside the toaster while it's working, the hottest wires are white, and the cooler wires are more red. So that's the same with stars, because so some of the less hot stars, which are about 3,200 degrees Celsius, they appear reddish, and the hottest ones with temperatures of over 20,000 degrees Celsius on the surface appear bluish. And the sun is about 5,500 degrees Celsius, so it appears yellow.
Why I love that. Let's talk about size. So, when you look at stars, they all seem to be like around the same size, but many stars are actually about the size of the sun, and the sun is like kind of like a medium star. It's a medium star. So most stars are much smaller than the
Sun.
So this is a white dwarf, and it's about the size of the Earth. Right now we're using Right now we're using water balloons as an example. So this is a white dwarf. It's about the size of the Earth. I've said it 5 times, but this, however, is a neutron star. So this is a medium-sized star, also known as the sun. The sun, like I said earlier, is medium-sized. So this is the sun. The next biggest one is a large star. It's a little bigger. And the last but not least, though, the giant star. Here we go, giant star.
Woohoo!
The biggest we could get is bare.
It's a horrible representation, but that's okay.
So this is the biggest we could get it. Bear with us, but you know. So Jesse will now talk about chemical composition of a star. Let's go. Teleport!
So now I'm going to talk about the chemical composition. So stars vary. A star's chemical composition varies from star to star. The chemical composition of most stars is about 73% hydrogen, 25% helium, and 2% other elements by mass, which is similar to the mass of the sun. Astronomers use something called a spectrograph to determine the elements found in stars. A spectrograph is a device that breaks light into colors and produces an image in the resulting spectrum. Most large telescopes have spectrographs. The gases in a star's atmosphere absorb some wavelengths of light produced within the star. When the star's light is seen through a spectrograph, it leaves each absorbed wavelength is shown as a dark line on the spectrograph. Each chemical element absorbs light at a particular wavelength, just as the person has a unique set of fingerprints. By comparing the star's spectrum with the spectrums of known elements, astronomers can infer how much of each element is found in the star.
What? Okay.
Come like the ones I used to know. Meow.
Okay.
Ellie, I'm gonna die.
can do the
Blooper.
Yeah. You know, flow. Oh, I'm in Clara hair. I'm in Clara. Oh, this looks so stupid.
Their chemical.
The star's
chemical chemical composition. Huh. It's hard to say.
a star's chemical composition.
Varies.
A star's chemical. So great.
What?
This is why I'm not in choir. This is why I'm in band.
I love it. Rectangle's great. Really? This is not a star. What? God. Yes, it's true. Yeah, it's.
And stop rolling your eyes. Roll.
The eyes are just rolling out of my head.
Different directions.
Bye bye eyes, I'm going blind.
Okay, at least be like, what the fluke is this video?
Sorry that you had to go pee.
Hold my hand. You remember the last slow motion one?
I know she's not.
Okay, ready? Are we starting? Those are great abs. I read Allie.
Oh, because I have great abs. You got
Allie starts with an A.
And whenever you hear Allie, you think of great abs.
I'm Squanto. I have great abs.
Squanto?
Yeah, I'm Squanto. Oh, I make corn with my abs. I make cornmeal with my abs.
Splish!
Well, actually.
Yeah. Because we were like, wait, what? It was weird. Oh, see Kristen goes,
Hurry so we have time to do the... Oh, they're deflating. Can she pop away for this part?
yeah, she can pop away. Oh! Do you want?
It's okay. It'll be... God!
What? Hello there.
Do that, yeah. Oh, there's something in my eye.
Well, there's something in my eye. Wait, I'm supposed to do that?
What?
I'm supposed to do that?
No.
Why, hello there. Let's talk about style.
Oh, I just cut off your head.
Determine the elephant. Elephants found in stars? Elephants!
She went to throw things and she took this in your bag.
Ellie! Stop it! Oh, the thumb thing! Sorry, we're gonna do that loud. Okay.
Oh, the thumb thing. Sorry, we're gonna do that loud. Okay.
Stop! You're falling more than I would.
Go.